Good evening, everyone. My name is Albert. This is Chris, and we're Team Alpha. Pretty much the overview of our project is going to be a scaled mini version of Fastrak. Everyone here knows how a Fastrak system works, correct? So as we go into our presentation here, this is the background of a toll tag. So pretty much gist of the toll tag is it uses electromagnetic RFID electromagnetic fields to identify and track data. So the Fastrak Express lanes, the toll tags allow commuters to receive toll discounts for carpooling and motorcycles, as everybody knows. So you don't have to pay that. Well, now it's a $7 fee. Now it's going up, so you don't have to pay that.
It varies during different times of the day depending on the traffic.
Correct.
Usually there's a traffic management system that can tell how much traffic is going on. So more traffic means a higher fee to use the express lane. So with the Fastrak Flex, as you guys know, the tag has a switch that lets you select 1, 2, and 3. And depending on what setting you have, that'll give you certain discounts. So let's say for 1, you're paying full toll. 2, you get a discount, and 3 can be free. Depending if you have a high occupancy vehicle, which HOV stands for, and or a motorcycle. So let's go on to the next slide. So there's a lot of components to the express lane, but the main component that we wanted to focus on, which is something that you guys see every day. If you guys ever commute on 580, I'm pretty sure you guys have seen this all the time, is the beacon, the enforcement beacon. So the enforcement beacon is a visual display that CHP will use to basically verify whether or not people are using it properly, if they're paying the proper tolls, or if they're committing toll evasion and whatnot. So the most common form is basically a 3-light display. So 880 is a little bit different. You have 2 different companies that basically make those express lanes depending on who the person is contracted. So Transcore being for 880, they have a whole different beacon setup. But 580 is more the version that we're focusing on, which is made by GAP's Tripicon. So before anything was built, this was kind of an overall proposal that was made by Alameda County. This was for the 680 project, and basically you got your violation enforcement system, your camera and light, you got your sensor that basically senses the RFID tags within that zone. But our project is mainly focused on the beacon over here. So there's a little bit of different variation. Obviously it doesn't look like that in the finished product. For any of the express lanes, 680, 880, 580, you don't see any of that. It's very different, but pretty much it serves the same function.
And then pretty much the purpose for our project is to observe the radio frequency by the RFID applicator and efficiency in the lane enforcement.
We just want basically to demonstrate its uses and its effectiveness in lane enforcement.
With different RFID tags, will execute unique outcomes. So for example, with our project, the RFID tag setting 1 will have the first light emulate, RFID tag 2 will have 2 lights emulate, and RFID tag 3 will have 3 lights emulate alongside with a buzzer for each tag that the RFID tag passes through.
So the procedure, basically what we wanted to do, just to basically test this method, basically have 3 unique RFID tags that we're going to use. Each tag will be passed and propelled through a little motorized booster, basically a Hot Wheels track that we'll demonstrate. Each tag is mounted to a different car. So we wanted to test these, 50 passes each, so we're really testing to see cause and effect, see if it's reading it accurately, and if it's reading it completely, so if there's no failures to read. Results are still pending. Obviously, we have to get the kinks out of the system, make sure we got all the variables out before we can actually test. So the results are still on the way. So basically, we're just going to go through the whole step-by-step process and how we construct it. first step, obviously, RFID. No previous experience with Arduino, anything like that. This is all new to us, so this was definitely a learning curve. Programming, understanding how modules work, understanding inputs and outputs. So basically, what we're doing here, this is just prototyping. So what we were doing, we were just fiddling with the program, just assigning our inputs and outputs, and then we're testing the program using LED and a relay. So getting the RFID tag to trigger LED was our main goal, and this is basically what happens when you pass an RFID tag. And yeah, that was our main LED right here that we were trying to light up. Yep. And that's our whole mess of wires and whatnot.
So with the hot wheel booster for our track, we tried to modify it. Because one of the issues that we were running with is that the original booster was making the cars go way too fast, and it wasn't reading through the RFID tag, so it wasn't picking up any of the readers or anything like that. So we went ahead and modified it. We put a potentiometer on there to slow down the booster. But throughout the weeks we were working on the project, we pretty much blew that motor twice. So with that, we just went back to an original booster. We hooked it up to another DC power supply, so that's what we're running with it right now.
Yeah, this is just us just assigning inputs and outputs. We're just messing with the ladder diagram using CCW. So this is just basically hooked up to our beacon, which is right here. So what we wanted to focus on is just focusing on the illumination sequence of the beacon. So making sure that RFID 1 will light LED 1, and RFID 2 will light up 1 and 2, and RFID 3 will light up 1, 2, and 3. We didn't want it to be out of sequence and basically have it aesthetically unpleasing. So we didn't want RFID 2 to trigger 1 and 3 and then have a big gap over here. That's not what we wanted. We just wanted to make it pleasing. Typically, if you're working with projects, obviously your customer, those things matter to them. So you definitely don't want to do that, especially if it's a multi-million-dollar project. So yeah, once we got that everything tested, we tested the circuitry for function. We made sure that the ladder diagram was working, or the ladder logic was working just fine, and everything was in sequence. So basically, we just began our construction. So everything here made from scratch. No parts were bought as a kit. Everything was kind of assembled basically off of our imagination. So just trying to make it look similar to what you would see in some highways. So we got conduit elbows run over here. We got a little conduit body kind of serving as a junction box over here. We have mending plates used to mount everything. Basically what they call that apparatus on the freeway, they call it a trapeze. So we got as close as we could, realistically, dealing with the modules that we have, just to make it work. So got that. We had to make our own custom wire harness, and we had to terminate each wire. After that, pulling everything through over here and running them to the appropriate modules. And basically that's our finished product over here. So we got wires running through here into the junction box, and we got 3 outlets, one coming to the beacon, one coming to the buzzer, and one coming to the RFID sensor.
And this is pretty much just an overview of our box as we were going through the weeds. Just our progression. This is us testing in the classroom, pretty much with nothing mounted. And then as we go, the track, just to keep it steady, we went ahead and drilled it to the board that we have here, and just various pictures of us constructing the entire project and how it looked before everything was harnessed up and cleaned out.
So basically, one of the issues we ran into when we put everything together, huge issue obviously, the main component, RFID sensor wasn't reading any of the tags or when it did, it was very intermittent, and we didn't know why. Obviously, so the first thing we looked for continuity within the harness. This was running through a pretty tight, path. So the original harness was made from 22 gauge, which is really thin, and obviously pulling it through with a lot of tension and moving it back and forth quite a bit, you never know, you've got the short. But testing it with the multimeter, we did have continuity, so that wasn't an issue. So we moved on to the next step, which we had the help with of Mr. Nabil. He looked through our program. So he basically looked at our program, cleaned it up a little bit, and then tried that. And the program worked, but we still had the same issues. It was still functioning intermittently. So at that point, we pretty much ruled out that it was going to be a hardware issue. And by luck, we found out that it was something simple. You want to go for the first picture? So this area circled in red is the problem that we had. So basically the screw was touching this component right here, which I believe is an oscillator. So that basically makes the circuit function with a certain frequency. And we had a metal screw and touching this part of the circuit, which I guess caused it to not work properly. So whenever RFID passed, it just wouldn't read at all. So easy fix, we just replaced those screws with nylon screws. So no metal to metal contact whatsoever. And that basically solved our issue. So this is our program. Basically, this is the raw version of our program. This isn't the one that Nabil cleaned up. His looks much cleaner, but they both perform about the same. Mine just has a little bit of extra stuff here. So basically, over here we're just assigning. Over here we're assigning our output pins over here. Going down a little bit more. The loop is basically based off an if statement. So if it reads a certain tag, it'll trigger certain outputs. So over here, let's say for RFID 1, which is setting 1 for the Fastrak, that's our RFID tag. So whenever it reads this tag, it'll trigger output 4. RFID tag 2 will trigger output 5, and RFID 3 will trigger output 6. And those outputs will feed into the PLC, which we'll move on to the next step. So basically, this is our ladder diagram. Super simple, nothing crazy about it, just one output for each rung, and we just have branches on rung 1 and 2. So the way that the lights work, you already know RFID 2 and RFID 3, they'll all light LED 1. They'll light at least the first LED, and then RFID 2 will light 1 and 2, and RFID 3 will light 1, 2, and 3. And for the fourth rung, that's basically for the buzzer, and every single RFID is going to activate the buzzer just to give an audible confirmation that the RFID tag is being read. So basically, yeah, our main goal is just to see cause and effect. So here's pretty much our results of what happened.
So as it goes, as you guys see the chart on here, so LED 1, RFID 1 will trigger LED 1, but it will not trigger LED 2, LED 3, but it will trigger the buzzer. As you see, each one will trigger the buzzer. So RFID 1, LED 1, RFID 2, LED 1 and 2, RFID 3, RFID 3, LED 1, LED 2, and LED 3.
So basically, based on the results, it proved our hypothesis to be correct based on our analysis. You know, RFID 1 triggered LED 1, RFID 2 triggered LED 1 and 2, RFID 3 triggered LED 1, 2, and 3. And so, yeah, conclusion: each RFID tag triggered a specific number of LEDs accordingly to their specific ID. They didn't have any different outcomes based on the inputs. So. Very consistent, no misreads, and that's pretty much it. Overall, it was a success. Obviously, with electronics though, you know, especially if you're kind of in the early stages of construction, you're gonna get a little bit of bugs here and there, so it takes a little bit of tweaking. So not everything's perfect, but for the most most part, we got all the major stuff completed, and everything works as needed. Just a little bit of fine tuning that needs to be done. So Alfred, he'll demonstrate for you basically our beacon in action. So if you guys want to gather around, you guys can
So
come
you guys
closer
can
to us.
see the LEDs itself. Alright, so as you run the booster, just run the cars through. You see it green LED for the signed RFID tag.
Nice.
So obviously, RFID tags, there's so many different forms. You know, the form of our RFID tag that we're using a passive RFID tag. So it's powered by the sensor, basically. You know, there's other ones. I believe the Fastrak Flex uses an active RFID tag, so it's battery assisted. You know, so depending on what type of reader that you have, what type of sensor, you know, obviously the more advanced ones have a much farther range, and they tend to be a lot more powerful. So those tend to be much more reliable. Obviously, we're using hobby grade stuff, so that's going to be a little bit limited. That's why our range is so low. Obviously, if you had something more powerful, it wouldn't have to be so low; it'd be higher, just like how you would see in a real express lane. But overall, that's our demonstration. Hope you guys enjoyed it.
Thank y'all.
This is great. Yes, yes. All right. Questions from the audience?
How long did it take you guys to build it all up? You got a lot going on.
It took a while. Honestly, the hardest part, was just messing with the programming with the microcontroller board. This one was definitely a learning curve. Like we said again, we didn't have any experience doing this. It's just something we kind of had to piece together. So luckily, we were able to get things to work well enough to function for this project. But overall, we did everything in steps. So I want to say total construction time in reality was probably about a month. Everything else was really just trying to get the kinks out and trying to coordinate and plan everything together. So yeah, nothing crazy. Just a little bit of attention to detail. Just just working on this circuitry. Just trying to use the skills that we learned in our previous classes. Obviously, like ESYS 51, just soldering, basically making sure everything's right, make sure the circuits are proper. So basically the LEDs over here, they're all powered by the same source. It's just the PLC is controlling which LEDs get illuminated. It's just basically completing the circuit, and they're all running on a common ground. So based on the RFID, that'll trigger which circuits are being closed. So
You also want to pay very close attention to the wire management. If you see how the wires are wrapped in spiral wrap, as well as managed in the cable housing. So we know there's a lot of wiring in this assembly, in addition to what goes inside those bent tubes. That is all very, very well managed, and we see very little spaghetti wires, if you will.
Yeah, basically our reasoning too, as well. Obviously, we wanted to protect the wire. We're using aluminum plate over here. It has sharp edges on it. I didn't do anything to smooth it out, honestly. So the last thing we wanted was a short circuit or anything like that. So definitely our main goal was to protect the wiring. Either from tension or from abrasion or shearing. So yeah, that's basically why we just ran it through a shrink tube, and we put wire loom over it as well. Especially with this one, we didn't want any power getting cut and severed and making contact with any other metal parts and causing any electrical hazards for us. Luckily, for the most part, most of it's low voltage. We're running our system off of 5 volts. The highest voltage is only the PLC and the power supply. So.
Yeah, because that's what it looked like without P&A.
Yeah, it basically was a bird's nest before we cleaned everything up.
Oh yes, there it is.
Obviously, there are better ways to do it. There are a lot more methods. You can run wires different ways. You can put more Panduit in different areas to clean things up. Because this is just basically a very raw setup. There are other ways to do it, like
So let's say for this microcontroller over here, they actually make an accessory, a little terminal block attachment. So you can actually mount this, and then you'll have terminal blocks for each specific pin input and output over here. So that would allow you more options, a more secure connection, and basically you have these running everywhere, and then you can kind of customize how you want to run your wires. But obviously, since this is all just coming in vertically, obviously there's not really much of a way to do it without stressing the wire. So this is basically a raw setup. Obviously, it can use more refining, but you know, in due time we can do that. But for the most part, our main concern was just to get it to function.
I think the wire management looks great. Question?
I like it, it looks good. I see that there are a lot of wires and that you have them all under control by either running them through the black tube or binding them up.
Thank you.
Thank you.
Mm-hmm. Other questions or comments? Okay, another round of applause for a well-constructed project. Great job, guys. Outstanding, outstanding.
If you guys want to, you guys can run the track if you guys
Yeah,
want.
you guys can play with it.
Yeah, you should see this thing work. It's beautiful.